another way to solve quadratic equations, this time by the square root property. Remember the words, the solutions of an equation, the roots of an equation, or the zeros of an equation can all be used interchangeably when you are asked to solve an equation. Also, quadratic equations can have one, two, or no real solutions. Standard form of a quadratic is ax squared plus bx plus c equals 0. And what term seems to be missing in all of these problems below? So let me scroll down so you can take a look. If we have ax squared plus bx plus c, what term is missing? It's the bx term. The easiest way to solve a quadratic when the bx term is missing is by taking the square root of both sides once the x squared is isolated. A quadratic equation will have no real solutions if the term under the square root is negative. So I'm going to work through some guided practice problems, and the homework problems will be yours to solve. Okay, so let's find all the real solutions, give exact values of rational solutions, and state irrational solutions as simplified radicals. If there is no real solution, write no real solution. Okay, so on number 1, we want to isolate the x squared on one side. So first we need to divide by 3. So the 3's will cancel and we'll get x squared equals 16. And then to solve for x, you just take the square root of both sides. And so now we'll get x equals plus or minus 4. Because positive 4 squared and negative 4 squared equals 16. Okay, now for the next one. First we need to get that x squared term by itself, so I'm going to add 5 to both sides. And now I'm going to divide both sides by 2. So I'll get x squared equals 9. And now that my x squared term is isolated, I'm going to square root both sides. And I'll get x equals positive or negative 3. So you'll see so far number 1 and number 2 have 2 real solutions. Okay, and then number 3, divide both sides by 5. And then we take the square root of both sides. And we'll get x equals positive or negative square root of 6. And that's actually our answer right there, because we're not going to evaluate it. We're just going to make sure it's a simplified radical, which it is, and so we can leave that irrational solution just like that. Okay. Now on to the next example. Number 4, we have x squared equals negative 25. So whenever we go to square root this, we get x equals positive or negative square root of negative 25. But that is not a real, we cannot take the square root of a negative number and staying in real numbers. So for now, we'll just say there's no real solutions. Okay. Number 5. Get the x squared term by itself, divide both sides by 2. We get x squared equals 40. Now we need to take the square root of both sides. Okay, so we'll get x equals positive or negative square root of 40. But the square root of 40 can be simplified further. So if we have the square root of 40 and we want to simplify it, remember that's the same thing as 4 times 10. And I'm choosing those numbers because 4 is the largest perfect square that is a factor of 40. And now that I have those two factors separated, I can separate out the square root of 4. And then that means that we get the square root of 4 is 2, and the square root of 10 cannot be simplified anymore. So x equals positive or negative 2 square roots of 10. Okay, now number 6. Take the square root of both sides, I get x equals positive or negative square root of 85. I need to think, can that be simplified anymore? And as it turns out, you cannot simplify the square root of 85 anymore because the factors of 85 are 5 and 17. Those are both prime numbers, so that's as simplified as that one gets. Okay, in the next few, we have x squared equals 300. So again, take the square root of both sides. I get x equals positive or negative square root of 300. I have to think, can 300 be simplified? The square root of 300, can it be simplified any further? So if we have the square root of 300, well, what's the largest perfect square I can get out of 300? Well, quickly I can see that it's 3 times 100. The square root of 100 is 10, and the square root of 3 cannot be simplified anymore. So you'll see in number 7 and in number 5 there's two different ways. Here I split it up into two separate radicals, and then number 7 I kind of skipped that step and left out the part where I split it into two, but this is another way you could do it, and that's fine. So now x equals positive or negative 10 square roots of 30. Okay, number 8. Again, get the x squared term by itself, so I'm going to divide both sides by 5. So I get x squared equals 11 over 5. Take the square root of both sides. So I get x equals positive or negative square root of 11 over 5. But that is not a simplified radical. So if I have the square root of 11 over 5, that can be split into two separate radicals, square root of 11 over the square root of 5. And then I want to rationalize my denominator, so I'll multiply the top and the bottom by the square root of 5. So on the bottom we get square root of 5 times the square root of 5 is just 5. And then on the top we'll have the square root of 11 times the square root of 5. So that's the same thing as the square root of 11 times 5, which is 55. Therefore, x equals positive or negative square root of 55 over 5. Okay, number 9. First we need to add 5 to both sides and then divide by 4. Okay, now when I take the square root of both sides, I'll get x equals plus or minus. If I split that into two separate radicals, that's the same thing as the square root of 17 over the square root of 4. Well, the square root of 4 is just 2, so I have plus or minus the square root of 17 over 2. And that's your answer right there, because square root of 17 cannot be simplified anymore. Okay, so just a few more problems. Number 10, we have x squared equals 20 over 3. Well, the x squared is already isolated. That means we can go ahead and take the square root of both sides. So I get x equals positive or negative. Instead of the square root of 20 over 3, I'm going to split that into two separate radicals. It's the square root of 20 over the square root of 3. I don't want to leave the square root of 3 in the bottom there, so I have two options, because the square root of 20 can be simplified further. So you can either do that, or you can rationalize the denominator first. It doesn't matter. So if we were to, let's go ahead and rationalize the denominator first. So now I've got plus or minus the square root of 20 times the square root of 3. Well, that's the square root of 60, because 20 times 3 is 60. And the square root of 3 times the square root of 3 is 3. Well, 60 If we think about the factors of 60, we have 1 and 60, 2 and 30, 3 and 20, 4 and 15, and 4 is a perfect square. And as it turns out, 4 is the largest perfect square that we can get from 60. So I'll get x equals plus or minus. So I have 4 and 15 is the same thing as 60. So that 4, the square root of 4, and I have 15. 15 will stay in there, but the square root of 4 is 2, so I have plus or minus 2 square roots of 15 over 3. And that's your answer right there. Number 11. So here we have x plus 3 squared equals 16. You do not have to FOIL this out. You can leave it as x plus 3 squared. The squared term is by itself. So we could take the square root right there. The square root and the squared cancel, so we're left with x plus 3. And the square root of 16 is plus or minus 4. So when I subtract 3 from both sides, I'll get x equals negative 3 plus or minus 4. Well, that can be simplified further. So if I have x equals negative 3 plus 4, negative 3 plus 4 is positive 1, and negative 3 minus 4 is negative 7. So those are both of our solutions. So we have two solutions again. So number 10 had two solutions because it had a plus or minus. There's the positive 2 square roots of 15 over 3, and there's the negative 2 square roots of 15 over 3. There's two solutions, and number 11 has two solutions as well. Okay, number 12, I'll take, again, the x minus 4 is all squared, so we can take the square root of both sides. So we'll get x minus 4 equals this positive or negative square root of 15. Then if I add 4 to both sides to solve for x, the square root of 15 cannot be simplified anymore. So therefore the answer is x equals 4 plus or minus the square root of 15. Okay, now for number 13. So first I'm going to subtract 6 from both sides so I can start getting that x squared term by itself. To get x squared completely by itself, I'm going to divide both sides by negative 3. So I get x squared equals 7 over 3. I want to take the square root of both sides to solve for x. So I get x equals positive or negative square root of 7 over 3. But I want to rationalize this denominator because this is really the same thing as the square root of 7 over the square root of 3. So to rationalize, I multiply the top and the bottom by square root of 3. So now my denominator, square root of 3 times the square root of 3 is just 3. The square root of 7 times the square root of 3 is the square root of 7 times 3, which is 21. And that's my answer. X is plus or minus square root of 21 over 3. And then the last one, we have x plus 3 over 2 all squared equals 25 over 2. So I could take the square root of both sides. And I get x plus 3 halves equals positive or negative. I'm going to go ahead and split the square root of 25 over 2 into the square root of 25 over the square root of 2. That's the same thing. Just so you know. Those are the same. Okay, and then I'll have x plus 3 halves equals positive or negative. The square root of 25 is 5. And if I need to rationalize this square root of 2 denominator, I'll multiply the top and the bottom by the square root of 2. So if this became 5, which is down here. Now I multiplied it by the square root of 2, so I'll have times the square root of 2, and then the square root of 2 times the square root of 2 is 2. So I have x plus 3 halves equals positive or negative 5 square roots of 2 over 2. So if I subtract the 3 halves from both sides, I'll get x equals negative 3 over 2 plus or minus 5 square roots of 2 over 2. So you'll see that these have the same denominator of 2, so we can simplify it one more step to be x equals, so since the denominators are equal, I'm going to put it all over 2, and on my numerator I have negative 3 plus or minus 5 square roots of 2, and that's your answer. Okay, well that's it. Let me know if you have any questions, and I will see you later. Bye.